Okay, I'd like to acknowledge my co-lead on this project, Dr. Jillian Holloway at Fiera Biological Consultants. Okay, yes, that's a pie, a peach pie, in fact. So there's many ways to divide up the complex pie of cause-effect or effects assessment monitoring of boreal landbirds. At EC, we're working on a variety of projects to address key questions. And these include questions that allow us to look at diverse designs, to use innovative analytical approaches, and to work with a series of partners, including the Alberta Biodiversity Monitoring Institute, the Boreal Avian Modeling Project, the University of Alberta, and some of our industry partners, in particular Brian Energy. My key projects and project leads are shown on this slide in green. Today I'm just going to talk about the project on the lower left, additive and cumulative effects. Okay, so this is my key message slide. I will repeat this slide again at the end, but you can just quickly read it over, and that's all I'm going to say about it because we're going to talk about it at the end. Okay, so the boreal forest, in particular the boreal forest in northern Alberta, is composed of a series of pervasive and intensive threats from multiple simultaneous stressors. And these occur because of industrial forestry, because of conventional oil and gas extraction, and because of bitumen extraction. And it's resulted in this landscape full of multiple stressors. This is a true multi-stressor landscape. These stressors do not exist in isolation. So there's multiple types of cumulative effects. And cumulative effects, as I'm defining them here, are the combined effects of multiple individual stressors on species and ecosystems over space and/or time. There's two types of effects that I'm going to talk about today. There's additive effects, and this is just when you add individual stressors together. So the combined effect is equal to the sum of the individual stressors, so A plus B. So you can see on my slide on the left there, I've got a harvest unit and the addition of a pipeline. So where these two occur in a landscape, you would add them together, and that would be the sum of the effects. But there are also interactive effects, and this is just when you multiply individual stressors together. So the combined effect is equal to the interaction among the individual stressors. So you can see on the left, or on the right here, A plus B plus A times B. So there's two types of interactive effects. There's effects that are synergistic, so that's when the interaction of stressors is actually greater than their additive effects, or antagonistic, and that's when the interaction of stressors is actually less than their additive effects. I think I alluded to this yesterday. There's been a series of meta-analyses in the last few years, both in terrestrial and marine environments. These are comprehensive and international in scope, and they've actually found that that over 77% of studies that have examined cumulative effects actually identify interactive as opposed to additive effects. So why do I think it's important to assess additive versus interactive effects? Well, there's a lot of reasons, primarily because of the level of uncertainty. If effects are interactive, it means that we represent a major source of uncertainty for projections of biodiversity. If effects are interactive and synergistic, it means that future rates of ecosystem and biodiversity decline will absolutely be underestimations. If effects are interactions and synergistic, future rates of ecosystem and biodiversity decline will be more rapid than if they're additive or interactive and antagonistic. If effects are interactive, our understanding of these complex interactions and the associated mechanisms will require more study. And finally, and I think most importantly, if effects are interactive, understanding these mechanisms and the direct and indirect effects of these mechanisms will be required to develop effective and efficient management actions. Okay, so I had four main objectives of this study. The first was that I wanted to look at the impact of multiple stressors on boreal landbirds. I wanted to examine which sector or sectors had the greatest impact and which key stressors had the greatest impact. I wanted to look at whether effects of multiple stressors were either additive or interactive, and I wanted to look at some predicted impacts on our suite of boreal landbirds. Okay, I'm just going to really briefly talk about some of our design and methods. We categorize disturbance within the Athabasca oil sands area using a natural breaks optimization analysis. We selected our survey areas across a gradient of forestry and energy sector disturbance. We surveyed a cluster of 9 point counts over a period from 2011 to 2014 within each survey area. And this totaled about 279 survey areas and just over 2,500 point counts. So you can see my study area in this slide. This is the Athabasca oil sands area. Even though over this period of 2011 to 2014, I've been collecting data throughout the 3 oil sands areas, Athabasca, Cold Lake, and Peace. This is only a subset of my data. I also did not sample within the mineable oil sands area, primarily because of safety and logistical concerns for my staff. And I also want to point out that these survey areas shown on the map are targeted and stratified to capture the gradient of forestry and energy sector disturbance. Okay, I'm just going to talk really briefly about some of our modeling work. Our sample unit here was a cluster of point counts, not individual point counts, so that the scale was appropriate to the way we assessed a landscape disturbance. Our response variable were the summed counts within a cluster. I used Peter Salimas's density estimator to adjust those counts to density. And I only modeled, even though I had much more data, we only looked at species with about 30% occurrence because we wanted to create credible and rigorous models that met our standards. Our predictor variables were simply the habitat and stressor areas summaries for harvest units, roads, narrow linear, which is 2D and 3D seismic in this system, wide linear, which is primarily pipelines but also power lines, and impermeable features, which here include things like steam-assisted gravity drainage sites, other types of conventional and oil sands-related facility sites, work camps, human settlements. We created habitat disturbance models, and I'm happy to talk about the structure of these models at the break, but I won't talk any more about them. And finally, we compared our models and assessed support using an information theoretic approach. So I really want to point out, importantly, that we developed a series of model groups in this analysis. So in any IT approach, you're comparing a series of models. We built a group of 17 models, and there were 5 model groups. Our first model group was the null model, which is a habitat-only model. Our second group was the all disturbance model, which just considered the area of individual stressors without considering whether or not they actually co-occur in space or time. And then we created these 3 different model sets: a forestry model set, a forestry energy model set, and finally an energy model set. And each of these 3 model sets contained a series of hierarchical, additive, and interactive models. And they actually represent the pattern of development in the Athabasca oil sands areas. So they actually relate quite strongly to how development occurs over time through exploration to extraction. So just as an example, to give you an idea, a simple example of what an additive model looks like compared to an interactive model, I'll refer you to the forestry set here, number 3. So an additive model would simply be harvest units plus roads. The comparable interactive model here is harvest plus roads plus harvest times roads. Okay. So I'm going to talk about a series of our results. We're preparing this work. We're running our final model run. So these are penultimate results I'm going to present today. And we are currently preparing our manuscript. Okay, surprisingly enough to us, for our 30 species, we had extraordinarily high model selection certainty for 27 of our 30 species. So what I mean by that is we only had 1 model selected from our 17 models with a delta AIC value of 0 and a weight of over 90%. That weight means that there's 90% probability that this best model was in fact the best model in the candidate set of 17 models. We only had a little bit of model uncertainty for 3 species, and by that I mean I still had weightings close to 60% for each of these species. And for every one of my 30 species, an interactive model was the best model. So I'm just going to graphically show you what that means here. So again, this is just the sum of the number of species with the best models in each of my 5 model groups. So you can see on the x-axis, this is just the model groups. the 5 model groups I just talked about, and on the y-axis is just the number of species. So again, I had no species where the best model was either in the null group, the all disturbance group, the forestry group. I had 17 species where the best model was in the forestry energy group, and 13 species where the best model was in the energy group. So what that really means is that the main effects for boreal landbirds are explained by interactive models that include forestry and energy stressors or energy stressors. Okay, so what types of stressors are important? Okay, so for each, I'm going to present 2 slides here, and they're the same 2 species. So bay-breasted warbler, which is a late successional conifer-associated species. Its best model was in the forestry energy model group. And for each stressor variable in the best model, what we did here is we calculated predicted values across the range of observed values that appeared or occurred in the Athabasca oil sands area, holding all of the other stressors at mean values. So what we're presenting here on the x-axis is just the area of disturbance that's standardized between 0 and 100, and the predicted counts on the y-axis. And you can see here that for the bay-breasted warbler, and the last thing I want to say is the importance of the stressor variable is actually indicated by the slope of the line. So I'm pointing here to some red arrows. So again, I want you to pay attention to the slope of the line. So you can see here for the bay-breasted warbler that both harvest units and wells showed a strong negative response. We saw a weak positive response to roads and a weak positive response to vegetated linear. We think for numerous species, we're actually seeing a sampling bias towards roads, just because you can't avoid roads in Alberta. I'm going to show you some results for the Alder Flycatcher. This is an early successional species, so an open habitat species. Again, its best model was in the forestry energy set. And I think here I'm seeing sort of an opposite pattern. So we're seeing a very strong positive response to harvest units, a weaker positive response to vegetated linear, and a weak negative response to wells and roads. Okay, so what's the difference between an additive model and an interactive model? Again, for the bay-breasted warbler, I'm showing you the same interactive model in the solid line, and I'm also showing you the additive model. And again, these are calculated the same way with predicted values using the range of observed values that occur within the Athabasca oil sands area. The way to sort of think about comparing an interactive model and an additive model is that an interactive model contains the individual terms, so for example, here if you're looking at harvest unit, but it also includes the interactive terms or the multiplicative terms that include harvest units times wells or harvest units times roads. Whereas the additive model shown in the dotted line for harvest units would only include the single individual term for harvest units. So you can see here for the bay-breasted warbler, for both harvest units and for wells, the interactive model shows the stronger negative effect. You can see the same type of pattern for, again, the Alder Flycatcher, where the solid line represents the interactive model, the dotted line represents the additive model, and you can see, again, a stronger response of the interactive model over the comparable additive model. So finally, what we wanted to do to really make sure that we believed what we were seeing is that we wanted to look at some predicted impacts on some of our boreal landbird species. Our estimated predicted counts, we actually calculated them in our current landscape, so that's our 2014 landscape, full of disturbance, and a no disturbance landscape, which is really a 2014 landscape with 0 disturbance. So again, I want to emphasize this is not a spatial or temporal backcast. This is a 2014 landscape where we took out all the disturbance. We were able to do that using historical disturbance data supplied to us by AESRD and ALPAC, and also using adjacency rules. So what we found were that we found really varied responses for our 30 species. We found negative responses for 10 species, positive responses for 12, and neutral responses for 8. And what does that look like? Well, Well, it looks like this. So if you check out this plot here, on the x-axis I've got just a few of the species that we modeled, and on the y-axis I've got predicted counts. In the brown bars I have my current landscape, and in the green bars I have the no disturbance landscape. So I'll refer you to the far left. The bay-breasted warbler and the red-breasted nuthatch are two species that showed negative responses. And what I mean by that is they had lower predicted counts in the current disturbed landscape than they did in the no disturbance landscape. And I also want to draw your attention to the species in red above that. These were other species that also showed a negative response. The boreal chickadee, the Cape May warbler, winter wren, palm warbler, Lincoln sparrow, and gray jay. The bay-breasted warbler, red-breasted nuthatch, Cape May warbler, winter wren are all species associated with old, late cirral forests in Alberta, old deciduous, old mixedwood, old spruce forests. The other species, the boreal chickadee, the palm warbler, and the gray jay are all species associated with black spruce forests. So the middle of the plot, you can see the alder flycatcher and the dark-eyed junco. These are species that showed positive responses, so higher predicted counts in our current landscape. Some other species that showed positive responses, the black-capped chickadee, the black and white warbler, the American robin, and the least flycatcher. And finally, on the far right of the plot, you can see my results for the chipping sparrow, which is again a species that showed a neutral response. Other species that showed neutral responses were the mourning warbler, the Tennessee warbler, ovenbird, white-throated sparrow, and the common raven. Okay, so here I am back at the beginning. We found that we saw cumulative effects resulting from both forestry and energy sector stressors. Key stressors that we examined included harvest units, wells, vegetated linear features, and roads. We found that cumulative effects were overwhelmingly interactive and not additive. Interactive effects, to me, strongly suggest both direct effects of habitat loss and indirect effects of habitat degradation or edge effects or other types of complex mechanisms like predator-prey dynamics. Impacts on boreal landbirds are diverse. They're not all negative. They can be positive. They can be negative. They can be neutral. And finally, these impacts on landbirds are definitely complex. I think this really points in the direction of work in true multi-stressor systems to characterize and quantify mechanisms of response. Some of the work that we're doing right now in SAG-D systems is that we're examining the effects of SAG-D disturbance across a gradient on both community metrics and also individual metrics like home range size, space use, and reproductive activity on both specialists and generalists. I think that this also points to the direction of using these results to develop both effective and efficient management actions to both reduce and mitigate impacts on boreal landbirds. And finally, I want to acknowledge my supervisors, Dr. Samantha Song and Dr. Dave Duncan, my term staff, in particular, Thea Carpenter, who's been working with me since January 2012, and a whole legion of field technicians. I can attest, because I went with them, that I sent them to a lot of terrible places. And high on my list are, let me see, shrubby bogs with horizontal willow, recent burns with overwhelming amounts of wind throw. I really want to commend them for their perseverance and their love of boreal birds. Thank you.
Okay, we have a minute or two if there are any questions. Yeah.
Uh-oh.
Hi, Lisa. Thanks for that. I'm Jillian Donald. I am here as a consultant for Fort McMurray Métis. I just was wondering, Lisa, if you could comment on the applications of this kind of modeling approach for preparing project approvals. So when an environmental impact assessment is done and there's a species habitat models done in the wildlife components, do you foresee that the results of your work here could influence that process? And also, if the assessment to wildlife, or well, birds in particular, I guess, for all disturbance, not just the major commercial projects, because some projects don't have any real evaluation of wildlife effects in the project approvals. They just do a desktop survey of what's been observed previously. So I just wondered if you could make a comment on that. Thanks.
I really hope that these types of results inform future work. I don't think these results are surprising to anybody who spent a lot of time working on birds in the boreal. I think, if you look at, I'm a big fan of David Lindermeyer, and I think if you look at his models, his conceptual models of landscape change, I think these really support that kind of work. I think in the boreal, we're moving from an intact landscape to a very much variegated one, where we have a perforated and dissected system, and we're starting to see those types of impacts on birds. So I think, we did this work really to explore some of these key questions that we've been wondering about. We just haven't had the type of data to do it. And the problem with this type of work is it requires an astounding amount of data to cover this kind of covariate space. I think Jim alluded to this earlier today. It took us 4 years and thousands of point counts to achieve this. And I can tell you that it took a lot of work to get into these places. So yes, I guess I'd like to see this type of work applied, but it's going to take a lot of effort to do that.
Hi, Carolyn Campbell from Alberta Wilderness Association. Thanks a lot for the presentation, and definitely strong message there about interactive effects. So I just wanted to double check, because you know the literature way more than I do, and you just maybe alluded to it. Some of the species that showed neutral, I was a little surprised by, thinking they would be more negative. So, was there anything in there, say, that was a surprise, or in other directions that you weren't expecting? And I guess the second question is, given that you were in a range of habitats, is there useful information, or at least useful methodology, to point to more wetland-reliant species?
Well, first of all, no, I wasn't very surprised by some of these results. Like I said, these are, I still consider these preliminary results. This has been a very long iterative process. I think we've done 8 model runs at this point. So there's a few more tweaks that we are going to make. All human footprint is not created equal, and you have to be very careful in the way you combine stressors, because birds show opposite responses in terms of the magnitude of response and the direction of response, even to very similar stressors that, as biologists, I would think, oh, that's a successional stressor, I'd expect them to respond similarly. They do not. So no, and the patterns that we're actually seeing, the birds that were showing neutral responses, many of them from our niche work, identifying habitat guilds and specialization and generalization, those species come out as being true generalist species in terms of their niche association. So, or they're early serial species, which again, I'm not surprised at seeing neutral or positive responses for those birds. And I'm trying to remember your second question. It was... Yes, right, so I'm currently working in lowland systems right now, in black spruce dominated systems. I do think that these are very complex systems. Structurally, these are simplistic forests compared to deciduous forests or mixedwood forests or even white spruce forests. But the birds that are found there appear to be quite specialized in the way they use habitat. So I think in the past we've done a lot of focusing on upland habitats in the boreal, and as part of the work that I've been doing over the last 4 years, I've really been trying to fill the gradient of habitat types, habitat disturbance types, including all sorts of upland and lowland habitats, forested and non-forested.